Question 1. So, when copper sulfate solution reacts with sodium hydroxide solution, a precipitate of copper hydroxide and a solution of sodium sulfate are formed. And they've given me the equation: copper sulfate plus sodium hydroxide makes copper hydroxide plus sodium sulfate. The formula of the sodium ion is Na+. What is the formula of the sulfate ion? So if you didn't know that the formula of a sulfate ion was SO4 2-, which it is, you could work it out. They're telling you, here's the formula for sodium sulfate. They're telling you that sodium is positive, and we know from the formula that there are 2 of them. So that gives me 2+ overall. And for an atom, I have to have balanced charges. They cancel each other out. So that means that sulfate ion, okay, must be 2-, because 2 pluses and 2 minuses cancel out to make an atom. So my answer is SO4 2-. Part B, 10 centimetre cubed samples of copper sulfate solution were placed in 5 test tubes. Different volumes of sodium hydroxide solution were added to these test tubes. The volumes of sodium hydroxide solution added were 1 centimetre cubed, 2, 3, 4 and 5 centimetres cubed. In each test tube, a precipitate of copper hydroxide was formed. Okay, I'm just going to write down here that I remember that a precipitate means a solid, okay, just in case I've forgotten. Okay, so I'm making a solid, a precipitate of copper hydroxide. The precipitate was allowed to settle, and the height of the precipitate was measured with a ruler. So here's the solid. So they've mixed those 2 solutions together to give us a solid of copper hydroxide precipitate, and that's formed at the bottom, and they're measuring the height of the solid that forms. So the results are shown in figure 2. So here's figure 2. So let's have a look at it. So along the bottom on the x-axis, we've got the volume of sodium hydroxide solution added. So 1, 2, 3, 4, 5. And then on the y-axis, we have the height of the precipitate formed in millimetres. Okay. So it's asking us, first of all, to draw a line of best fit to complete the graph. So I'm going to use a ruler to do this, and I would do it in pencil ordinarily, but I'm doing it in pen so that you can see it. But in your exam, you need to do it in pencil, and you need to do it in pencil in case you get it wrong so that you can rub it out. So a line of best fit. Okay, I'm going to put my ruler, and line of best fit means where most of the dots are hitting the line, most of my points. So I'm going to go for there. I'm going to start at the first one and finish on my last point. So there's my line of best fit. I'm going to tick so I've done that. Predict the height of precipitate. Okay, so that's what I'm going to try and find out. The height of the precipitate that would be formed if 6 centimetres cubed of sodium hydroxide solution was added to 10 centimetres cubed of copper sulfate solution. This mixture would contain excess copper sulfate solution. Okay, so I'm working out the height based on 6 centimetres cubed. Now, I'm not going to guess this. I'm just going to be really careful and get my answer right. So if I go back to my graph here, this is my 6. Okay, 6 centimetres cubed of sodium hydroxide. And so I want to read off the height formed. Now, I can't do that. I can't just guess where it might be here. So I'm going to extrapolate. I'm going to extend my line, okay, up to 6. There it is. And then again, I'm not going to guess this. I'm going to draw a line up to 6 until I hit my line. There. And then I'm going to take it across until it hits the y-axis. And then I can read it off really carefully because there's no room for error here. I have to be really exact. Okay, so I'm going to read it off my scale. Now, I've got 5 squares, which is worth 2 millimetres. So that means that each little square is 4.4. So 14.4, 0.8, 15.2, 15.6. So I'm reading it carefully off my y-axis, and I read it as 15.6 millimetres. Okay. So the copper sulfate solution has been prepared by dissolving 6.36 grams of solid copper sulfate in water and making the volume up to 250 centimetres cubed. Okay, so let's just make sure I know that. So I've got 6.36 grams of solid copper sulfate, and I'm dissolving it in 250 centimetres cubed of water. So calculate the concentration of the copper sulfate solution in grams per decimetre cubed. Okay, so this is what I've got to be careful here with my units. Okay, I've got, that's grams, that's correct, but my volume, they've given me in centimetres cubed, and I've got to give my answers in decimetres cubed. Okay, give your answer to 3 significant figures. So I'm going to highlight that bit too, because actually I don't want to get that bit wrong, lose a mark for that. Okay, so the first thing I have to do is I've got to convert my 250 centimetres cubed into decimetres cubed. Okay, so then I'm in the right units already. So to do that, I have my 250 divided by 1,000, okay, and that gives me an answer of 0.25 decimetres cubed. So instead of now saying that I'm dissolving 6.36 grams in 250 centimetres cubed of water, what I'm saying now is that I'm dissolving 6.36 grams in 0.25 decimetres cubed of water. Okay, so now I use my concentration equation. So concentration is my mass divided by my volume. Okay, so let's slot in my numbers. My mass, 6.36. My volume, now in decimetres cubed, 0.25. So that gives me an answer of 25.44. Okay, but I've not quite finished because I need to give my answer to 3 significant figures. So 1, 2, 3, 25.4 grams per decimetre cubed. Part D, copper ions, Cu2+, react with hydroxide ions to form copper hydroxide. Write the ionic equation for this reaction. Okay, so I'm going to look back just to my previous page, because actually this whole question, I'm still on question 1, and they've given me the equation at the beginning here already. So I know that copper hydroxide has got the formula Cu brackets OH close brackets 2. Okay, so I'm making CuOH2. Okay, and then they want me to write the ionic equation. Okay, so I'm only going to have to use the copper with the hydroxide ions to make my copper hydroxide. Okay, so here's my copper 2+. I'm going to add in my hydroxide ions, which are OH minus. Okay, you need to remember that hydroxide is OH minus. Okay, and I've done it, but actually it's not balanced. Okay, so here I've got one copper, OH, I've got 2 of them, so I'm going to add a 2 in the front. So that tells me that 1 copper ion reacts with 2 hydroxide ions to make 1 copper hydroxide molecule.